Hello guys, hope you have been having a very lovely day. In this video, I would like to show you a MATLAB tutorial and how to convert a transfer function into a state model. So I'm clicking new button, new script on the MATLAB window, and clicking on this new opens this editor. So I'm gonna type the program which will help me convert the given transfer function, which I'll be taking as an input from the user, into a state model. If you ask me the um, advantages of a state model, it's because transfer function has certain limitations when we need to find out a few things. So we use state model, and state models are not limited to SIS4, that is single input and single output. So to overcome those limitations, we use state model. And this state model, I tell you, can be different from what you obtain from theoretical calculations, because uh, it all depends on our assumptions. But if you are going to convert this state model into transfer function again, you'll get the same transfer function. That will be right. So for the given set of A, B, C, if you're taking all of them from the same, then it's gonna be right. Because based on your assumption, the contents of A, B, and C can differ. So this is my code, which I'm gonna execute in the command window. Num is equal to input of numerator. You're gonna take input from the user, the numerator of the transfer function, and denominator also you're going to take input from the user. And finally, ss of tf of num comma den is the actual syntax which is going to convert the transfer function into a state model. So tf of num comma den first converts the numerator and denominator into a transfer function, and ss of this transfer function gives you the state model. So let me just click the save and run, the green button on the toolbox here, toolbar. So I'm clicking that, and I'm gonna name my program as um, YouTube 1. So that command is for saving as well as running. So now my command window has opened, and YouTube 1, that is the name of the program. You can also execute a program by setting the correct path of the program where you have saved it, and then typing the name of the program here. So by doing that, you can start you can execute things in the command window. So I'm going to enter my numerator by starting a square bracket, because I have two terms in numerator. My numerator is s plus 3. So I'm going to write 1 space 3, because if I'm going to write only 3, it means my numerator is 3. If I'm writing 1 space 3, my numerator is s plus 3. If I'm writing 1 space 3 space 4, my numerator is s squared plus 3s plus 4, and so on. And so if I have to write s squared plus 3, which means I don't have an s term, I'll have to write 1 space 0 space 3, because if I'm not writing that 0, the system is gonna understand that it is only s plus 3. So in my case, the numerator is s plus 3, so I've written 1 space 3, and the denominator is 1 space 3 space 2, which is s squared plus 3s plus 2. So this is my numerator, and that is my denominator. So as you can see, busy showing in here. So yeah, you'll have to, yeah, it's here. So now first the transfer function has been calculated inside itself, and what we want is the output of it. So the answer is this. You have A matrix, B matrix, C matrix, and D matrix, where A is equal to -3, -2, 1, and 0. B is 2, 0 column matrix. C is 0.5 and 1.5 a row matrix, and D is 0. So based on the system's assumptions, most of the time D is always 0. So this is how I'm going to find out the state model of a transfer function using MATLAB. you can there is a very simple way to find out the state model from a transfer function using theoretical calculations, which I'll be doing in another video. Hope you found this video very informative, and if you're having an exam tomorrow or anytime, all the very best, and have a lovely day. Thank you.